We're now going to talk about the intermediate value theorem. So here's the theorem here. I'm going to give you a chance to read it and I'm going to explain this. So f is a polynomial, and for a is less than b, so we're talking about number line a and b here. If the y value at a and the y value at b, that's what these stand for, have opposite signs, then f has at least one zero on this interval. So basically all this is saying is that if I evaluate the graph at one x value and I evaluate another x value and they have opposite signs, so one negative, one positive for instance, then basically this theorem says that the graph has to cross the x-axis somewhere in between though. That's the only way the sign can change between y values. So that's what the intermediate value actually says. So for this picture right here, we know that because this is negative and this is positive, we know that the graph has to cross somewhere between there. So this theorem basically guarantees that there would be a zero somewhere between a and b. So now that you have a chance to take a look at the theorem, let's apply it and look at an example. Okay, so for our example, intermediate value theorem, IVT, determine whether the intermediate value theorem guarantees that the function that's listed here has a zero on the interval -1 to 1. Okay, so we have to use the theorem to show that there's a zero. So what we just talked about before in the description of the intermediate value theorem is that if you can show that if you evaluate the function at each of the endpoints and you see that they have opposite signs, then that guarantees that there's a zero on that interval between -1 and 1. So all we're going to find here is we're going to put -1 into our function, and then we'll put 1 into our function. Okay, so first, if we want to say that f of x is basically equal to y in this case, we're going to evaluate f of -1, and we're going to evaluate f of 1. So we just plug that into each one here, and that's going to tell us whatever sign value we get for each one. If it's opposite sign, that guarantees that there's got to be a zero between -1 and 1. Okay, so let's do that for this one. -1 to the 7th minus 4.5, -1 to the 5th plus 5.0625, -1 to the 3rd. We want to take this and put this into our calculator, and so I'm not going to show all that, but if you put that into the calculator, the value that you should get there with -1 is negative value here, -1.563. Okay, so that's the value if you plug -1 into the original one. Let's put 1 into this one for all the x's. So 1 to the 7th power minus 4.5, 1 to the 5th plus 5.0625, 1 to the 3rd. So essentially we have 1 minus 4.5 plus 5.0625. If you work all that out, you're going to get 1.563. We get a positive value for that. So therefore, because we got a negative and we got a positive here, that guarantees that there has to be a zero on the interval between -1 and 1, and we say that's because of the intermediate value theorem.